Hello everybody, glad to see you again. We'll talk today about cotton and hemp. We begin this unit with two of the most versatile and historically important textile crops, cotton and hemp, as I said. These plants have provided fiber for thousands of years, shaping not only clothing and textiles, but also industry, trade, and even culture. Cotton is famous for its soft, fine fibers, which are ideal for spinning into yarn and weaving into fabrics. Hemp, on the other hand, produce long, coarse, and very strong bast fibers from its stem, used traditionally in ropes, sails, and durable cloth. Today, both crops go far beyond traditional textiles. Cotton seed oil and meal are valuable in food and feed industries, while hemp is increasingly recognized for biocomposts, insulation, paper, and even construction materials. By starting with cotton and hemp, we place ourselves in the intersection of tradition and innovation. Plants that are thousands of years old, but those important is just as strong in modern industry, particularly in the context of green economy. Before analyzing each crop in detail, let us first define textile plants. These are plants specially cultivated for their fiber, seeds, or stems, which serve as raw material for the textile and related industries. Textile fibers can come from different plant parts: seed hairs in the case of cotton, bast fibers from stems in the case of hemp and flax, or sometimes even from leaves in the tropical species. What they all share in their adaptability to be processed into yarns, fabric, ropes, and a wide range of industrial products. The importance of textile crops lies in their dual role. They are at the same time agricultural commodities and industrial resources. This means they can connect the farmer's field with global value chains in textile, clothing, paper, composite, pharmaceuticals, and bio-based materials. By understanding their biology and cultivation, we can see why certain crops fit better in some regions, how they adapt to environmental conditions, and how their products answer both traditional needs and modern innovations. Some things about cotton, hemp, and flax. A short overview. In this section, we will focus on three major textile crops: cotton, hemp, and flax. Each of them illustrates a different biological strategy and industrial use. Cotton belongs to the Malvaceae family and produces seed fibers. It is the world's leading natural textile fiber, dominating global production. Hemp, from the Cannabiaceae family, is an annual crop with fast growth, delivering bast fibers from its stem that are exceptionally resistant. Flax, from Linaceae family, has been cultivated for thousands of years, both for fiber and for oil, making it one of the most multifunctional crops. Together, these three represented of the backbone of traditional textile industry, which also contributing to the modern applications such as eco-friendly composite, medical textile, and biopackaging. Their combined study allow us to compare different plant morphologies, cultivation requirements, and economic potentials. About global distribution and importance, cotton, hemp, and flax are cultivated worldwide, but each has its own geographical core. Cotton dominates warm regions from the United States and Brazil to India and China. Hemp thrives in the temperate climates with moderate rainfall, historically in Europe and Asia, and is now emerging under modern green policies. Flax is the best suited to cooler, humid regions such as northern France, Belgium, and Eastern Europe, where the fine fiber reach top quality. Globally, cotton remains the most important in terms of production volume, but hemp and flax are experiencing a renaissance thanks to their ecological profile and their role in sustainable industries. The significance of these plants extends beyond textiles. They generate byproducts such as cotton seed oil, hemp seed, or flax meal that contribute to food, pharmaceuticals, cosmetics, and bioenergy. In short, textile crop from a strategic agricultural group linked farming to diverse industries and responding to both economic and environmental challenges. Biological particularities. When we study textile plants, it's essential to start with their biological characteristics. Cotton, hemp, and flax are very different botanically, yet they share the common feature of producing high-quality fibers. Cotton is a shrub-like plant with seed hairs that elongate into familiar soft fibers. Its growth cycle varies between 150 and 200 days, depending on the variety and climate. Hemp is a fast-growing annual, reaching up to 3-4 meters in height in only a few months, with a strong taproot and a hollow stem. Flax, on the other hand, is a slender plant about 70-120 centimeters tall, with a fine stems that provide the bast fiber used in linen. Biological, the fibers come from different tissues: cotton from seeds, epiderms, hemp and flax from stem bast. That explained why their cultivation techniques and processing chains differ. Understanding these biological particularities is key because it helps us connect with plant physiology, with fiber yields and quality. Cotton, biology and cultivation. Cotton is the most widespread fiber crop. It requires warm climate, long frost-free periods, and abundant sunlight. Germination begins at soil temperature above 15 degrees Celsius, and the crop develops best under average daily temperature between 21 and 30 Celsius degree. Its biology is fascinating. The fibers are actually elongated seed hairs that grow directly from the outer epidermis of the seed coat. They start elongating soon after fertilization and continue to thicken with cellulose deposition until maturity. The length and the strength of this fiber determine the quality of cotton yarns. From the agronomic perspective, cotton is demanding in terms of water and nutrients. Irrigation is crucial in dry areas, and nitrogen plays a key role in promoting vegetative growth and ball formation. Cultivation practices also involve pest control, as cotton is vulnerable to aphids and other pests. Despite these challenges, cotton remains the leading fiber crop globally, covering millions of hectares and supporting entire economies in Asia, Africa, and Americas. Hemp's traits and cultivation. Hemp, Latin name Cannabis sativa, is one of the oldest cultivated plants, and it's a remarkable example of agriculture versatility. It is a fast-growing annual that can reach 3-4 meters in height in just 100-120 days. Its hollow stems contain a long bast fiber and that are among the strongest natural fiber in the plant world. From a cultivation point of view, hemp adapts very well to a wild large soils, provided they are very well drained. It prefers moderate climate and can tolerate cooler temperatures during early growth. One of its greatest advantages is the adaptability to outcompete weeds naturally, reducing the need for herbicides. Traditionally, hemp fiber were used in ropes, sails, and textiles. Today, interest in hemp has expanded dramatically. It is cultivated not only for fiber, but also for its seeds and oil, which are valuable in nutrition and cosmetics. Modern uses include biocompost for cares, eco-friendly insulation, paper, and even sustainable construction material such as hempcrete. Because it is grown very quickly and requires relatively few inputs, hemp is increasingly seen as a sustainable crop in the future, supporting both agriculture and green industry. About flax, some environmental requirements. Flax is another traditional fiber crop cultivated for thousands of years and famous for its producing linen. Its cultivation, however, is closely linked to specific environmental conditions. Flax thrives in cooler, temperate climates with sufficient rainfall. High-quality fiber requires about 600-700 millimeters of water throughout the growth cycle, distributed evenly. Excessive drought reduces fiber fineness, while excessive humidity increases disease pressure. Temperatures around 18 to 20 degrees Celsius during the growth period are ideal. Soil must be fertile, well-structured, and moderately moist. Flax does not tolerate heavy clay or compact soil, or not perform very well on sandy, nutrient-poor soils. The best results come from loamy soils with neutral pH. Crop rotation is also important, since flax is sensitive to soil-borne diseases. It should not return to the same fields often than once in every 5 or 6 years. These strict ecological requirements explain why flax is concentrated in certain regions, such as northern France, Belgium, the Netherlands, or part of Eastern Europe. In these zones, the combination of soil and climate produces the finest fiber in the world using the high-value textiles. About modern agricultural technologies. Modern agriculture has profoundly transformed the cultivation of textile plants. Where traditional systems relied heavily on manual labor, today we can see mechanization, advanced fertilization, and precision farming shaping the way these crops are grown. For cotton, Mechanized sowing and harvesting are now standards in most large-scale production areas, particularly in the United States, Brazil, and Australia. GPS-guided tractors and drones monitor plants' health, water stress, and pest outbreaks, allowing intervention at the exactly right time. Hemp, once labor-intensive to harvest and process, is also benefiting from mechanization. New decortication machines efficiently separate bast fibers from woody cores, enabling hemp to compete in modern industries. Flax, too, is harvested and specialized equipment that preserve fiber length and quality. Technology also extends the irrigation systems, soil sensors, and digital platforms that provide farmers with real-time data. The integration of technology increases yields, reduces input waste, and ensures that textile crops meet the demands of modern industries for both quality and sustainability. Fiber formation and photosynthesis. The formation of the textile fiber is closely tied to plant physiology, especially photosynthesis. In cotton, the fibers are seed hairs that elongate as long as the plant supplies carbohydrates from photosynthesis. Strong, uniform fibers depend on a constant flow of sugar produced by the leaves. In hemp and flax, fibers are located in the stem best. Their quality is linked to the growth rate of the plant, cell wall thickening, and cellulose deposition, all of which rely on the photosynthetic activity. Adequate light, water, and nutrient supply during the main growth phases are critical to fiber strength and flexibility. This explains why environmental stress, drought, nutrient deficiency, or insufficient sunlight can drastically reduce fiber yields and quality. Simply put, photosynthesis is the engine that powers fiber formation, and managing it is the key of successful cultivation. Some factors in fiber yields and crop formation. Several factors influence the final fiber yields on textile plants. First, genetics. Improved varieties and hybrids can significantly increase both fiber length and strength. Second, environmental conditions. Temperature, rainfall, and soil fertility play decisive roles. Agronomic practices are equally important. The timing of sowing, plant density, fertilization, and weed or pest control all influence crop development. For example, in flax, high plant density leads to longer, finer fibers, while lower density produces coarser fibers. In hemp, nitrogen fertilization boosts stem growth, but excessive doses may reduce fiber quality. Finally, crop management during harvesting and reaping, the controlled rooting process that separates fiber from the woody tissues, is critical. Poorly timed harvest or improper rating can damage fibers, reducing their industrial values. So, when we talk about fiber yields, we must think of it as a result of a delicate balance between genetics, environment, and human management. Climate impact on development of these textile plants. Climate is one of the most decisive factors in textile plant development. Cotton requires a long frost-free season and plenty of sunshine. In cooler or cloudy regions, the crop cannot reach maturity. On the other hand, extreme heat during flowering can cause ball shading and yield loss. Hemp is more tolerant but still sensitive to extreme conditions. Drought during early growth reduces stem elongation, while excessive rainfall near harvest increases diseases and risk uncomplicated retting. Flax is particularly climate sensitive, thriving only in cool, humid regions where growth is steady but not excessive. Climate change brings new challenges. Unpredictable rainfall, more frequent droughts, and heat waves are forcing farmers to adapt to cultivation practices. Breeding programs now focus on developing more resilient varieties with higher tolerance to stress. In conclusion, climate is not only a background factor, it actively shapes the success or failure of textile crops. Adapting to its variability is one of the most central tests of modern plant cultivation. Soil requirement and fertilization. Soil is the foundation of textile plants cultivation, and each crop has its own preferences. Cotton thrives in deep, well-drained soils with good moisture retention, often alluvial or black soil. Hemp prefers fertile loams, well aerated and rich in organic matter, while flax is more demanding, requiring fine-textured, moist soil with a neutral pH to produce high-quality fibers. Fertilization plays a decisive role in both yield and fiber quality. Cotton responds strongly to nitrogen and potassium, which support ball formation and fiber elongation. However, too much nitrogen delays maturity and increases susceptibility to pests. Hemp needs balanced fertilization with phosphorus supporting root development and potassium enhancing stem strength. Flax requires careful phosphorus management to support oil and fiber synthesis, as well as adequate potassium for stem growth. What is common to all these crops is the need for balanced nutrition, not just maximum doses. Excess or deficiency of nutrients immediately affect fiber properties, making fertilization strategy one of the key levers of successful cultivation. Harvesting techniques. The harvest stage is critical because it determines the final quality of the fiber. In cotton, mechanical pickers or strippers are used in most regions. The timing of harvest is essential. Too early and fibers are immature, too late, and they are lose strength and brightness. For hemp and flax, harvesting is more complex. The stem must be cut or pulled in the right stage of maturity, usually when the lower leaves begin to yellow, but before full seed maturation. After harvest, the rating process began. This is when neutral microorganisms break down the pectins and that bind fibers to woody tissues. Rating can be done in the field, in water, or through controlled microbial inoculation. Mechanization has improved harvesting efficiency, but it must respect these biological windows. A single week delay can mean the difference between fine, high valuable fibers and coarse, low-grade material. In short, harvesting is not just the end of the cycle, it is a decisive step in the maintaining fiber integrity. Hemp, systematics and uses. Hemp, Cannabis sativa, Latin name, belongs to the Cannabiaceae family, and while the species is the same, as for medicinal or recreational cannabis, industrial hemp varieties are specifically bred to contain extremely low level of THC, below 0.2% in European Union. Hemp is one of the most versatile plants ever cultivated. Its bast fibers are among the strongest in the nature, historically used as ropes and textiles. Today, industrial use have expanded. Hemp fiber are blended into textile, used in eco-friendly compositions for cares and construction and for insulation materials. The woody core, known as hearts, is used in particle board, animal bedding, or even as raw material for paper. Seeds and oil are highly nutritious, rich in essential fatty acids, and widely used in the food and cosmetics industries. The wide range of applications explains why hemp is now considered a strategic crop for the bioeconomy with potential far beyond traditional textile uses. Some aspects about hemp cultivation. Cultivating hemp requires attention to several agronomic details. It thrives in temperate climate with moderate rainfall and prefers well-drained, fertile soils. The crop grows rapidly, up to 4 meters in just 3-4 months, making it an excellent competitor against weeds. Its natural weed suppression is one of the most hemp ecological advantages. It reduces the need for herbicides. Sowing density influences fiber quality. Dense stands encourage tall, slender plants with long, fine fibers, while lower density produce thicker stems and coarser fibers. Hemp also benefits from moderate nitrogen fertilization, but excessive doses encourage branching rather than straight stems, reducing fiber qualities. From a sustainability point of view, hemp is remarkable. It uses relatively few inputs, improves soil structure through its deep root system, and can be integrated into crop rotations to break disease cycles. These qualities, along with its industrial versatility, explain why hemp is re-emerging as a key crop in both agriculture and industry. Industrial exploitation of hemp. Hemp is regained global attention because of its industrial potential. Beyond its traditional textile use, modern industry exploits every part of the plant. The fiber are spun into fabrics, but more importantly, they are now used in composite for the automotive and construction sectors. For example, hemp reinforced panels are lighter and stronger than traditional plastics, reducing fuel consumption in vehicles and providing eco-friendly alternatives in building materials. The hearts or woody core are transformed into animal bedding, paper pulp, and even hempcrete, a lightweight, insulating, and fire-resisting building material increasingly used in sustainable architecture. Hemp, oil, and seeds are another growing market. The oil is rich in omega-3 and omega-6 fatty acids, making it valuable in nutrition, cosmetics, and pharmacy. Meanwhile, the residual hemp cake is used in animal feed. This capacity to provide fibers, food, fuel, and materials make hemp a model crop for the circular economy. Flax belongs to the Linaceae family and it's one of the most hostile domesticated plants in human history. Archaeological evidence shows that flax fiber were used for textile more than 7,000 years ago. There are two main cultivation types: fiber flax grown for its long, strong stem fibers, and oil flax grown for seeds rich in linen seed oil. The two types differ morphologically. Fiber flax plants are tall and slender with few branches, while oil flax plants are shorter and more branched, producing more seeds. Flax seeds contain up to 45% oil, rich in alpha-linoleic acid and highly unsaturated fatty acid with both nutritional and technical importance. The oil is valued in food products, paints, varnishing, and biodegradable materials. So, flax combines a long historical tradition with modern relevance, bridging ancient textile with today's industrial and nutritional uses. Flax thrives in cool, temperate climate and adequate rainfall. It is particularly sensitive to drought and heat stress, especially during flowering and seed development. This is why flax production is concentrated in regions such as northern France, Belgium, and Netherlands, which provide ideal conditions for higher quality fiber. The crop requires finely prepared seedbed because flax seeds are very small and need uniform soil contact to ensure good germination. Early sowing is recommended to take advantage of spring moisture and to allow sufficient time for plant elongation. Plant density plays a key role. High density sowing produces taller plants with thinner stems, which results in finer, longer fibers. Fertilization is generally moderate, as too much nitrogen encourages lodging and reduces fiber quality. Harvesting is delicate. For fiber flax, plants are traditionally pulled rather than cut to preserve fiber length. Rating then separates fiber from woody tissue. For oil flax, harvesting focused on maximizing seed quality and oil quality. Thus, flax cultivation requires precision, but when done properly, it yields some of the finest fiber used in luxury textiles. About flax industrial uses are diverse and expanding. From the fiber, we obtain linen, renewed for its strength, breathability, and durability. Linen textiles are increasingly in demand as consumers turn toward natural, eco-friendly fabrics. Beyond clothing, flax fiber are used in technical textile, ropes, and composite materials. From the seed, we obtain linseed oil, which has a unique drying property. It makes it invaluable for paints, varnishes, inks, and modern biopolymers. It is used in the food and pharmacy industry thanks to its omega-3 fatty acids and antioxidant components. The byproducts such as flax meal and sheaves are used in animal feed, particle board, and bioenergy production. Recent innovations include using flax fiber in lightweight composites for the automotive and aerospace industries. Flax is just a perfect example for a crop that combines tradition with innovation, maintaining its role in both cultural heritage and cutting-edge industry. About cotton, Systematics and traits. Cotton. It's a member of Malvaceae family, and it's one of the most important textile crops worldwide. There are several cultivated species, but the two most widely used is upland cotton, which accounts for about 90% of global production, and Egyptian cotton, famous for its extra long staple fibers. The cotton plant produces fluffy seed hairs, which are spun into worm and woven into textile. Cotton fibers are composed primarily of cellulose, up to 95%, giving them strength, softness, and versatility. The seeds themselves are also valuable. Once delinted, they are processed for cottonseed oil, protein-rich meal, and animal feed. Cotton stands out as a crop that is both ancient and modern, cultivated for thousands of years, yet still central to today's global textile industry. About cotton cultivation aspect. Cotton require warm climates with long frost-free periods, sunshine, and moderate rainfall or irrigation. Optimal soil are deep, well-drained, and rich in nutrients. The crop requires careful management of water and nutrients. Nitrogen supports plant growth but must be balanced to avoid excessive vegetative growth at the expense of balls. Phosphorus promotes root development and early flowering, while potassium enhances fiber quality. Modern cotton cultivation also relies heavily on breeding in biotechnology. High-yielding hybrids and genetically modified varieties resistant to pests have dramatically increased productivity in countries like India, China, and the United States. However, cultivation challenges remain. Cotton is highly susceptible to pests, as well as to drought or soil salinity. This is why integrated crop management and sustainable irrigation practices are increasingly important in modern systems. Cotton sustainability and industrial exploitation. Cotton is sometimes criticized for its environmental footprint, especially regarding water and pesticide use. However, major strides are being made towards sustainability. Initiatives such as the Better Cotton Initiative BCE promote responsible water use, reduced chemical inputs, and improved working conditions for farmers. For an industrial perspective, cotton is irreplaceable. It accounts for over 30% of all textile fiber used globally, despite the competition from synthetics. Cotton textiles dominate the clothing, household fabrics, and technical textiles. The seeds, often overlooked, are just as valuable. Cottonseed oil is widely used in food products, while cottonseed meal provides protein for animal feed. Industrial uses extend the cellulose derivatives from pharmacy, paper, and even explosives. Thus, cotton is not only a crop for textile, but a multi-purpose industrial plant, central to both the economy and sustainable development goals. So, thank you very much for your attention. And in conclusion, I would say cotton, hemp, and flax are not just traditional fiber plants, they are pillars of global agriculture and industry. Each crop brings unique strengths. Cotton for its dominance in textile and oil byproducts, hemp for the ecological advantages and versatility in new industry, and flax for its dual role in fine textiles and technical application. Together, these plants highlight how the agriculture connects with multiple sectors: textile, food, pharmacy, construction, and even renewable energy. They also show us that sustainability is not just an option, it is a necessity. So, thank you very much for your attention, and I hope this presentation has shown how these remarkable textile plants continue to shape our economy, our daily lives, and our future. Thank you.